At this point in our organic reactions understanding, we've done reactions of alkenes, and we've gotten a fair bit of practice with that, and possibly I've given you a sheet or sheets on other functional groups and reactions of those, and that might have felt a little bit overwhelming. On the other hand, to be honest, at the time I was making this video, I wasn't sure if the video would go first or the sheets would go first, so you may not know anything about sheets. Hopefully I made the right decision by the time you're seeing this. Okay. Once we move on to other functional groups, we need to kind of adjust our perspective a little bit. And what do I mean by perspective? If I take a look at one of the reactions of an alkene that was on your original page, it was taking an alkene and adding water across the double bond. And when I did that, I ended up making an alcohol. So I can do that as a reaction of an alkene, but I can also turn my perspective around and think about it from the perspective of, what if I wanted to make a particular alcohol? Well, if I wanted to make this particular alcohol, I could scratch my head and realize that, well, I could start with an alkene and do an addition reaction with it. So exactly the same reaction, exactly the same conditions, exactly the same everything. It's just, am I looking at it from the point of view of the reactants, or am I looking at it from the point of view of trying to make products? So that's going to make a bit of a difference while we're going through some of these things. Okay, now, if I scratched my head for a while and thought, I know how I could make that alcohol, could I also make it a different way? And the answer is yeah. There's actually two other ways that we'll have to make that exact same alcohol. I could start with an aldehyde, or sorry, in this case, it's a ketone, and I could reduce it. I could add hydrogen across the double bond, finishing up with the alcohol. Or I could do a substitution reaction where I'm taking a chlorine out and putting an OH group on. Well, which one is best? Answer is really simple. It depends. It depends on a couple of things. For our purposes, working on paper, all of these are going to be equivalent for this point. But if I were having to go one step further back, maybe one of them would be a little bit better than the others. Okay, I want to take another moment and look at oxidation, because it's one that we're going to be using a fair bit. So this was the original thing I showed you in terms of oxidation of carbon. And we're going to be focusing, as I mentioned at the time, just on the middle three, from an alcohol to an aldehyde or a ketone, possibly up to an acid. We can also go back. So as long as I've got control over the conditions and the molecule is going to behave, I can take an alcohol and I can oxidize it to, in this case, the aldehyde. I could also reduce the aldehyde back to the alcohol, and that's basically the reaction that you saw previously. Or I can take that aldehyde and oxidize it again up to the carboxylic acid. I can also take the alcohol and oxidize it straight through the aldehyde all the way to the acid in one step without really paying much attention to the aldehyde that happens in between. Why am I telling you this? Well, one of the things that we're going to see is on paper is sometimes people get stuck on one point or another point, forgetting that oxidation is just a continuous process. So I can start from the alcohol and go all the way up to the acid, or I could stop partway in between at the aldehyde, and it just depends on my reaction conditions. A question that you're going to be seeing, well, not this particular one, I guess, but you're making a fairly large molecule. So if I have over here, I've got a 2-carbon alkyl halide, and I'm going to be making a 4-carbon ester. And you would be asked to plan out a process where you could do that. And what I'm going to suggest is you always start with the product and just go one step back. So you'll hear me say this in class. You want to work forward, but think backwards. Okay, so instead of, no, I'd take that back. You're going to work backwards, but think forwards. Now you're going to be all turned around. Work backwards, but think forwards. So in other words, if I want to finish with that ester, what's one step back? How do I make an ester? You may have the sheets, you might not have the sheets, but at the end of the day, there's going to be one way we can make an ester. Lots of ways in reality, but for our purposes, one way to make an ester, and that's to start with a carboxylic acid and an alcohol. So I've taken that ester, and how do I make an ester? So I've worked backwards, but I'm thinking forwards. How do I make that thing? And the reaction conditions are there, and if you don't know that, because you haven't got the sheets, don't worry about it. Just follow along as much as you can. Okay, then what I would do is I would take just one of those molecules, and I'll take the other one later, and I want to figure out how do I make a carboxylic acid, because I don't have that. If you look at the question, the only thing I have is that alkyl halide. So I need to work back to it. Okay, how do I make a carboxylic acid? Well, previous slide said that I could start with an alcohol. If I start with an alcohol, I can oxidize it all the way up to the carboxylic acid. Yes, it would go through the aldehyde. I could have also gone to the aldehyde, but then I have to ask, how do I make the aldehyde? Okay, the next question then is, how do I make that alcohol? Well, I can make that alcohol a variety of different ways. We saw those earlier, but one of those ways, don't forget, was the alkyl halide, which fortunately is the alkyl halide that I was supposed to start with. And then I would have those reaction conditions. Now again, if the reaction conditions seem a little bit weird to you, don't worry about it. Apparently I decided to not give you this sheet first. The point is, I want to think about how do I make that product. So I'm working backwards, but thinking forwards. Okay, now I still have that other alcohol to make, but if I look at that alcohol and I turn it around in my mind, it's the same alcohol that I've got in just after the alkyl halide. So I could take my alkyl halide, divide it into two, no, I guess keep it all together, make a whole bunch of the alcohol, then divide it into two, send some of it to the oxidizer to become carboxylic acid, the rest of it stays as the alcohol, put them all back together at the end, making my final product. Okay, I know it's a whirlwind, but it's a lot of just having another chance to look at it and seeing an example, I think, I hope. Anyhow, here are the things that we'll be able to do by the time we're done with this unit. And once you get good at doing chemical reactions with it.